I have talked before about the value of performing analytics on the edge. And in some cases, it might be easy to understand. For example, think about a store like Amazon Go. If you haven't been to an Amazon Go store and don't know what it is, check out the article in the comments. An Amazon Go store is an automated store where they have hundreds of cameras in the ceiling on just a few square meters to automate the checkout process and tracking you throughout the store. And in this case, it is obvious that it would require an extreme amount of bandwidth to stream video from all these cameras to the cloud, where the analytics could be performed. But on a project that I'm working on right now, even performing time series analysis on one-dimensional sensors as temperature or other resource utilization can be almost impossible to do in the cloud due to bandwidth constraints. What I'm working on now is a project with building automation using nodes that communicate using LoRaWAN. This is a long-range, low-power protocol for wireless transmission, which allows us to transfer information on an open band network for many kilometers between the sensors and the receiver. And one of the use cases here is to perform anomaly detection on, for example, temperature sensors and other resources. And if we look at the bandwidth that we can transmit using LoRaWAN, we have a theoretical maximum of 27 kilobits per second. This is roughly half of an old dial-up modem. But factoring in legal limitations, like the legislations in EU, and some practical considerations, like maximizing the transmission range, then we could get down to a bandwidth as low as 11 bits per second. Yes, that's 11 bits per second. In this case, it's easy to understand that it's impossible to perform any kind of anomaly detection on the streamed data. So in this case, we need to move the analytics away from the cloud and put it in the detectors on the edge. So what we can do here is to use a microcontroller for the simple one-dimensional data streams. Here the many kinds of anomaly detections doesn't need a lot of CPU power, but can easily be performed on a battery-driven microcontroller. When doing time series analysis on video, we can select a camera which is even equipped with a deep learning accelerator, such as an Axis camera. And both these edge devices has in common that instead of streaming the raw information, we perform the analytics on the device and we just send an alarm trigger to the cloud. So in this case, we could, for example, send a trigger that an anomaly was detected together with the metadata such as the minimum value, the maximum value, and the average value for the temperature. So this would save us a lot of bandwidth. And this is only one of the many reasons that we might want to use analytics on the edge instead of in the cloud.